Welcome to the session 6, unit 6 of our financial modeling class. This seems to be the last session of our financial modeling course, and in this session we are focusing on the topical issues in risk modeling. That is, in the last session we focused on the risk, which is also covered in our last unit. So here we are going to consider other topical issues. By the end of this session, you should be able to explain the commonly used volatility measures by banks and financial institutions in controlling risk. You should be able to discuss the implication of getting the underlying distributions of returns wrong, and also explain the ongoing efforts, including new measures of volatility used by the financial institutions. So, we start again. We will ask, have you heard of the subprime mortgage that originated in the US and led to the global financial crisis? Have you come across the long-term capital management issues? What about the Lehman Brothers company? And what about the Enron? What about the London whale? So you can use your favorite search engine to search for any of these issues and read along, as they are quite important in one of the in this section, or in this the topic that we are going to discuss, that is risk. Back home, the news or recent news has it that financial and investment management institutions are in trouble, as clients cannot get back their investment. Currently we are facing such a situation in Ghana. The regulators of these institutions, that is the Bank of Ghana and the Security and Exchange Commission, have closed down these institutions and have their license withdrawn. We have seen several issues of such nature in our country. So we ask again, you want to ask, what then is happening? Risk management is very important to the survival of financial institutions. So this stands as the reason why financial institutions employ an analyst to help manage their risk. After expanding or widening our knowledge on the issues of risk, let them look at what are some of the measures that are put in place in valuing or measuring risk of firms, for instance, the bank or financial institutions. So every financial institution, especially banks, are required to make an assessment of how much of the bank's resources are actually at risk on a daily basis. Financial institutions are prone to sudden collapses, that is, they give out loans, they go through a lot of investment which are prone or which are likely or susceptible to failure, or which has the high tendency of failing. Unfortunately, the collapse of one institution weakens confidence in the whole financial system and may lead to the classical run on the bank. This is a concept. So when you say that the bank is having a run, it's more of having itself in a series of liquidation or have some form of problems or financial distress. It's for this pertinent reason that financial system regulators all over the world mandate financial institutions to report this important metric, which is known as value at risk, or simply VAR. VAR is defined as the maximum amount expected to be lost over a given horizon, or a specified given a specified confidence level. The Bank for International Settlement sets a confidence level of 99% with a time horizon of 10 days. This means that the potential value we expect to lose is calculated at 99% confidence level for the next 10 days, given that we are only likely to make an error which amounts to just 1%. Statistically, value at risk is a tail event, and this is illustrated below, that is in our figure 1. One thing that we have to understand is that in terms of risk, Our focus should be at the tail end, because it is the tail or the extreme activities in financial market that brings about the issue of risk, or that brings about the issue of uncertainties. So it is the extreme end, or the little issues, or the extremity of some of these market conditions that causes several losses on the financial market. Therefore, the value at risk seek to measure the tail, and this is, remember we said that in a plot, this is the average, and this is the positive returns, and this is the negative returns. Therefore, if we find, or if we are estimating a model considering this edge, that means we are simply looking at risk component, or the chance of we losing something. So the value corresponding to the arrows marked 99% and 95% on the horizontal axis are associated with the contours. These are the losses the financial institution will incur given some time horizon. So as we said earlier, these are the losses that we are likely or susceptible to make in the particular time horizon. There are several ways to calculate the value at risk. A common approach is the parametric method, which is popularly known as the variance covariance method. This method identifies the three elements of VAR, that is the time period, the value of assets, and the confidence level. We will consider this in our next slide. Using the variance covariance method or the parametric method, we simply have to multiply the quanta corresponding to the confidence level of the left tail, which could either be 95 or 99%, which was estimated earlier, by the value of the asset at risk, and scale this by the frequency required. So the frequency is simply the number of times the observation reoccurs. So suppose C&A Bank's total market value is 1 million Ghana cedis. It has calculated its daily returns to be approximately 0% with a daily standard deviation of 2%. What is the one-day VAR? What is the value at risk given a 95% confidence interval? So we approach the problem as follows. So given a confidence level of 95%, then it simply means that we have a significance level of the difference between the actual value, which is 1, and the confidence interval will be the risk that we are considering. So then we have 1 minus 0.95, which will give us 0.05. So the corresponding quanta from the Z table for this 0.05 is simply negative 0.1645. Therefore, the value at risk can now be calculated as the mu daily minus 1.645 times the variance or standard deviation daily. So this is the measure of the returns, the daily returns, or the average daily returns, and this is the measure of the daily average risk, or the standard deviation. So to cover this potential loss, we consider this further in our next slide. So let's substitute the given values into this our equation. So the VAR now becomes 0 minus 1.645 multiplied by 0.02 times the 1 million Ghana cedis, and the value now becomes negative 32,900. So it means we are likely to make these losses given the tail ends, or the tails, or the measure of risk that we, or the value at risk measure that we consider. For this potential loss, the regulator will require C&A Bank to put some capital aside to cover this potential loss. So you make good this loss by depositing some amount, or this amount, the tune of this figure, to cover this potential loss in the event that they occur. But the parametric VAR computed in the examples above has severe limitation. And it is based on the normal distribution. By using the normal assumption to calculate VAR, therefore, is inappropriate, given that in terms of risk, mostly we have already established that the normal distribution does not occur in the financial market, and that whenever the idea of risk is always come to mind, then we have to think about the tail dependence issues. So issues that deals, or a distribution that is mostly tail dependent, like in the gauge that we consider that it's better we use the student t distribution in measuring our in modeling our gauge than considering a normal distribution, because mostly the likelihood of we making an error or even the chance of we even incurring a loss always deals with the tail, or could be dealt with at the tail end of the distribution. Therefore, there is a need for us to consider the tail end and the average or the center. So in severe cases, the distribution of our returns could exhibit interesting shapes like the one that we show in our next figure. So in figure 2, there is some areas under the tail that is the case if the distribution was normal. So this does not look normal, and that we see that this is an issue of fat tail, because the tails are very heavy, and it should not be this is not the features of a normal distribution. As in a normal distribution, the tails should be like this one. So this is a normal distribution, but with this plot, this is the data that we use, and this is the plot. So as a normal distribution looks like this shows that we have an asymmetric distribution, or a distribution that is not normal. So there is a real danger of the financial modeler underestimating the risk of loss for this type of distribution, since the VAR relies on a point estimate. The financial institutions and their regulators are therefore on the search for a new measure to accurately estimate the risk. Perhaps you'll become part of the researchers in your career as a financial modeler. That is the near future. So we are simply saying that for us to model the VAR, then we should have the belief that the distribution or the data set can be distributed equitably like this normal distribution. But given the plot that we are seeing here, which is the orange line, there is a chance that this distribution is not normal given the heaviness of the tail. Therefore, using the VAR, which value at risk model, which depends on the normality of distribution, or which assumes the normality of distribution, is not appropriate. So in this session, we have explained the commonly used volatility measures by banks and financial institutions in controlling risk, and discussed the implications of getting the underlying distribution of returns wrong, and explained the ongoing efforts, including new measures of volatility used by financial institutions in addressing the issues of risk. We have come to the conclusion of this course, as this happens to be the last session of the last unit. Thank you for your attention, as you have been with us through these weeks of our discussion in our financial modeling course. We hope to meet you once again in another course.